Hello, this is going to be the part 2 for 10.5. On Friday, we were looking at the angles of elevation, and today we are going to focus on angles of depression. So on Friday, I told you guys we were going to be finishing this lesson on Monday. Sorry I couldn't be in class today, but you guys are going to have to watch this video. So angles of elevation we learned were the angle between the horizontal line and the line of sight when you're looking upward. So as we're looking upward and the angle that's created with the horizontal, that's called the angle of elevation. So it's usually the bottom angle in the triangle. But today we're going to learn about angles of depression. But before we get to that, we need to go over the new concept. So here it says that we have, and this is a Math 2 standard, but I'm not sure how much of this you learned from last year, but it says, remember when two parallel lines are cut by a transversal, so I can see my two parallel lines are going to be these green lines here. It says when they are cut by a transversal, so my diagonal line here is going to be the transversal line. It says alternate interior angles are congruent. So my alternate interior is this 50 and this one over here are actually congruent angles. So this 50 degrees is equal to this 50 degrees. And then I can also see this 130 is equal to 130. So these alternate interior angles basically means if you see the two parallel lines, these four angles are the interior angles. They are between the two parallel lines. So when they are cut by the transversal, the ones on opposite sides across from each other, like diagonally, on the opposite side of the transversal, those are actually going to be congruent. Those are called alternate interior angles. And so if we see in the triangle, I can build a triangle by having a vertical line drawn here, and then I have a right triangle. And so therefore I see this angle outside is going to equal this angle down here. So because of that, we have these angles of depression. So an angle of depression is measured from the top looking down. And so you can kind of remember depression, when you feel depressed, you're feeling down. So angle of depression, you're looking downwards. So, but specifically, it has to go with the horizontal line. And so it says, because the angle of depression and angle of elevation are actually alternate interior angles, the angle of depression and angle of elevation end up having the same measure. And so the angle of depression is going to be this outside angle looking downwards. It's with your line of sight with the horizontal line. So I can see the horizontal line, and this will be your line of sight, and you're looking downwards. So that is called the angle of depression. But because what we just learned here or reviewed, the angle, the two angles that are created with these parallel lines cut by a transversal, alternate interior angles end up being congruent. And so the angle of depression is this outside angle right here, angle of depression, and angle of elevation is this one. But I can see my two parallel lines right here are being cut by this transversal. So then the angle of depression and the angle of elevation end up being alternate interior angles, so they actually are just congruent. And so therefore angle of elevation and angle of depression are going to be the same. So anytime we see a context problem with angle of depression, just know it's basically going to equal the angle of elevation. So for example, here it says the angle of depression from the top of an 80-foot building to a person on the ground is 42 degrees. And then how far is the person from the base of the building? And then round to the nearest tenth. And so in this case, it's saying the angle of depression from the top of an 80-foot building. So that means that this is going to be 80 from top to bottom. So the angle of depression is actually going to be this angle on the outside of the triangle is going to be 42 degrees. 42 degrees right here at the outside angle. And then the question is asking us for how far is the person from the base of the building. So that's talking about the bottom of the building. So really I'm looking for this distance here is my x. Okay. But again, we just learned that angle of depression is actually equal to angle of elevation. So I can move my 42 degrees down here, and then it becomes kind of the same problem like we were doing on Friday. So then I can label my triangle for SOHCAHTOA. Because I have a right triangle, I can use SOHCAHTOA. So across the angle is the opposite side. Across the 90 is my hypotenuse, which leaves me with x as the adjacent. And then I see the opposite side has an 80. The adjacent side has my variable. And I don't have anything for my hypotenuse side. So I can cross out the hypotenuse and I'm left with TOA, which is tangent. So then to create my equation, I would write tangent of the angle, which is 42 degrees, is going to equal 80 over x. And then using algebra, we can solve for x. Multiply both sides by the denominator, which is x. The x's cancel. We get x tangent 42 degrees. It's going to equal 80. And then to solve for x, we have to divide by tangent 42 on both sides. Tangent 42 degrees on both sides. So then the tangents cancel. And then we're going to be left with just x. Is going to equal, and then just grab your calculator. So on your calculator, you're going to do 80 divided by tangent 42. So 80 divided by tangent 42 degrees is going to equal roughly 88.8. Oops. This is going to be 88.8, and our units is going to be in feet. 88.8 feet. And then we have to just write a sentence. So go back to the word problem and see what did we look for. We were looking for how far the person is from the base of the building. So we would say the person is about 88.8 feet away from the base of the building. Period. And that's my final conclusion written as a sentence. Okay. All right. For the sake of the video, I'm going to just put this example here. You guys can go ahead and pause the video and try the example on your own. Okay, hopefully you paused the video, and here's the solution. So here we had a water slide is 100 feet long, so that would be this piece 100 feet. The angle of depression from the top of the slide to a person on the ground is 78 degrees. And then the question is, what's the height of the slide? So it's asking for this. And then round to the nearest 10. So you can see angle of depression equals angle of elevation. Our variable is actually the opposite side. Across the 90s, the hypotenuse. We didn't have an adjacent. So this ends up being so. Sine of 78 degrees equals h over 100. Multiply both sides by 100 gets you 97.8 for the height. And don't forget to write a sentence. All right, so in this example here is going to ask you actually for the angle. Instead of giving you the angle, we're going to be looking for the angle. So here it says an airplane is 2.8 miles, the horizontal distance from an airport, flying at an altitude of 1.1 miles. The question here is asking for what is the angle of depression from the plane to the airport, round to the nearest degree. So then we have to figure out where are we going to put this 2.8 miles. Where do I put this 1.1 miles? And then where do I put my x? What is the angle of depression? And so here there's a keyword here. It says an airplane is a 2.8 miles horizontal. So horizontal distance runs left to right. So that means that the airplane is 2.8 miles horizontally from the airport. And then it's saying at an altitude is actually from here to here is 1.1 miles. And then the question is, what is the angle of depression? So depression, remember, is the outside angle looking downwards. So that's my x, but I know that the angle of depression equals the angle of elevation. So I'm going to move my x over here. And then we can figure out using SOHCAHTOA, my variable. So across the angle is the opposite side. Across the 90 is the hypotenuse side, which leaves us with 2.8 as the adjacent. So which side are we not using? I don't have anything for hypotenuse, so we cross those out. We're left with tangent of x degrees is equal to 1.1 over 2.8 is my adjacent side. And then to get the x by itself, we have to get rid of tangent. So to get rid of tangent, we take the inverse of both sides. Tangent inverse of both sides. And then the tangent inverse and tangent cancel. We're left with the measure of angle x is equal to tangent inverse of 1.1 divided by 2.8. And then we're going to grab our calculator to plug that in. On the classroom calculators, you're going to do second tangent. So second tangent. And we go 1.1 divided by 2.8. Close your parentheses and press equals. You should get like 21.4, but it's asking us for nearest degree. So 21.4 is going to be rounded off to 21 degrees. And then we have to write a sentence. So we can just say the angle of depression. The angle of depression from the plane to the airport is about 21 degrees. Period. And that's my final answer. Okay. All right, and here's a practice problem. You guys can go ahead and pause the video and try this on your own. Okay, hopefully you paused the video, and here's the solution. We have a boat 250 feet from the base of the cliff. We can see here 250. And the cliff is 400 feet tall. So the 400 goes here. And then what's the angle of depression? That's right here, which is also equal to angle of elevation. And then run to the nearest degree. This one you ended up having to use tangent. We have the opposite and adjacent side. That's TOA. We don't have a hypotenuse side, so we can't use sine or cosine. So we get tangent of x is 400 of 250. Take the inverse of both sides. So tangent inverse of 400 divided by 250 gets us 58 degrees. And then don't forget to write your sentence. All right, so that is the end of the lesson. We have a closure here. You can pause the video, read the question, and see if you can answer it. Okay, hopefully you paused it and tried it. Here's the solution. Okay, we were given the angle of depression is 18 degrees, which is equal to angle of elevation, 18 degrees. We have the opposite side is 50, the adjacent side is D. So this is going to be TOA. So we get tangent of 18 degrees equals the opposite side over the adjacent. So that's how we get this to be the answer here. Okay? All right, you guys have a good day.